Hey guys, so we are starting section 7.3 in our algebra and trigonometry book, but it's only a third section of our trigonometry study, and this section is called unit circle. So that's what we're going to be talking about. In this section, the learning objectives are you're going to be able to find function values for the sine and cosine of 30, 45 degrees, as well as 60 and 90 and 180. You will be also able to identify the domain and range of sine and cosine functions, find reference angles, and use reference angles to evaluate other trigonometric functions of other angles. All right, so I really like this picture right here, and it says looking for a thrill, then consider the ride on the Singapore Flyer, the world's tallest Ferris wheel. Located in Singapore, the Ferris wheel soars to a height of 541 feet, a little more than a tenth of a mile. Described as an observation wheel, riders enjoy spectacular views as they travel from the ground to the peak and down again in a repeated pattern. Now, why is this picture here? How is it relevant? Well, we are going to be talking about circles, and this Ferris wheel is definitely circular. And so you could imagine, as we talk about our unit circle and the points traveling on the unit circle surface, you may imagine yourself sitting in one of the carts and traveling along the circumference of this Ferris wheel. So now let's recall some definitions of a unit circle. A unit circle is basically a circle with a center at the origin, or 0, 0, with the radius of 1. And what that means is that it intersects the x here at +1 and a -1, and it intersects the y-axis, also the +1 and the -1 on the bottom. Okay, so this is a definition right here. So some things that happens with unit circles is some formulas are simplified due to the fact that the radius is 1. For example, of our formula that we used for circumference cut out by a central angle in radians, right? We had the formula for the circumference is radius times angle. It's called t in this instance, not theta, which is totally fine. But look, if our radius equals 1 and we substitute it into the formula, then the formula simplifies to just circumference equals t, or angle t. But that works only, this formula works only for a unit circle where radius equals 1. So it's a very convenient object to study. Now, I want to remind you again that basically our coordinate plane, otherwise known as Cartesian system of coordinates, is divided into 4 parts. So, or quadrants. We have quadrants are labeled in the order in which our angles rotate, the positive direction of the angles, right? So the first quarter is quadrant 1. The second quarter is quadrant 2, and then we have quadrant 3 and quadrant 4. All right, let's move on to the next slide. So In the past, in the previous video, we mentioned trigonometric functions of sine and cosine, and we want to focus on those functions again here in the unit circle, how it applies to the unit circle. So remember we said that the definition of a sine function, sine of t, by the way, usually we write functions like f of x. We put the argument in the parentheses now, and f is the name of the function. Now here the function is sine. It's a specific function, and it has its own name, and it's a function of an angle t, right? When t changes, the sign changes. But for shorthand, we're going to be writing just sine t. And same goes with a cosine. For the cosine, it's a cosine of t. That's the proper way to write it. But in a lot of books, they use a shorthand, just cosine t. But it's a function of the angle. Okay, so I want you to remember that. And so what's the definition of the sine of t? Well, first of all, let's go back to our unit circle and look at an angle t, which we have a terminal side that intersects our circle at a certain point, x, with coordinates x, y. Okay, so this point, if we put a perpendicular line to x-axis, that will give us the x coordinate of this point. And then if you basically draw a horizontal line, that will give you the y coordinate of this point. Now, since this is a perpendicular line, we have a 90-degree angle. So also we're looking at a right triangle with one of the angles that equals t. Now remember when we defined our sine of t function, we said that it's the opposite over hypotenuse. That was the definition of this function. Now, what is the opposite side of this angle t? Well, it's this length, right? This length of a triangle, which corresponds to the y coordinate of this point, right? So it's going to be y coordinate over hypotenuse. And what is our hypotenuse? Well, the hypotenuse is actually the radius of this unit circle. And because it is a unit circle, the radius is 1. So basically it's going to be y divided by 1 or just y. Okay, we'll use the similar logic for the cosine of t function. The cosine is adjacent over hypotenuse. That's again the definition. So where's the adjacent side to angle t? Well, it's right here. And as you can tell, its length is the same as the x coordinate of this point, right? So it's going to be x coordinate divided by the hypotenuse. And because it's a unit circle, then hypotenuse is 1. So the cosine t just becomes the x coordinate. Okay, so again, it's a simplification for the unit circle. If you're looking at the unit circle, then the sine function of this angle t would be just the y coordinate of the point on the terminal side where it intersects the circle circumference. And for the cosine t, it's just going to be the x coordinate of that same point. So basically, this is the relationship of sine and cosine and coordinates of the point on the circle. Remember the Ferris wheel? Okay, I want to point out here that it is true only when we are looking at a unit circle. Let's say, for example, that we were looking at a circle of a different radius, let's say 2. So our radius is longer and we have the circumference, another a circle with its circumference. Forgive my bad drawing, but this is what happens. Okay, and let's say we have this point here with coordinates x1 and y1. So I just want to point out that you're gonna actually you're instead of here, when you're figuring out the sine of this angle t, you're gonna so sine of t will be your point x1 divided by the radius of this circle, right? And the cosine function will be coordinate y divided by the radius of that circle. So I should have called all of them 2's to be consistent so that you guys don't actually get confused. But just a note, a side note, it doesn't matter what they're called, the principle is what matters. Okay, and the reason why these are simplified to just the x coordinate and the y coordinate, oh my goodness, guys, I switched those around, I just noticed. So this is, let's start over again. So what happens if your radius of the circle is not 1? Let's say we have another circle with radius 2, and we radius 2 is 2 units instead of just 1 unit. Then we have the circumference here of that circle. We're only drawing the first quadrant of it. Okay, and we have this point here that intersects our circumference with coordinates x to y2. Well, the definition of a sine function does not change. It's the opposite side over hypotenuse. So our opposite side is right here, and that is the y coordinate, y2 coordinate of this point. Okay, so we have coordinate y2, and then we have to divide by the hypotenuse, which is the radius, by r2. So it's going to be y2 over r. Now for the cosine of t, same thing. It's adjacent over hypotenuse. So we're going to have coordinate adjacent is this right here. So that's going to be the x2 coordinate of this point. So we have x2 divided by r2. So it's going to be x2 divided by 2 and 2 there. So you see, and I just want to let you know that this function, this value, when you calculate it, is going to be the same as the value at this point, because we're talking about proportions, and these two triangles are actually similar triangles, and their proportions, what that means is that their proportions are the same. So for the sine and cosine functions, since these are proportions, the proportions, again, in similar triangles are the same. So this is going to be the same as this coordinate y on the unit circle. And for the cosine, it's going to be the same as that coordinate x on the unit circle. All right, so that's why I'm saying that when you're using the unit circle, these functions are a little bit simplified because we don't have to be worried about dividing by the hypotenuse, because the hypotenuse is always 1. So basically, when we're talking about those trig functions, we're always going to be concerned with the x and y coordinate of this point that travels on the unit circle. And I want to show you an illustration and in motion. So as you watch it, just think about how do x and y coordinates of the point on a circumference change. So here we are, we have our circle, and here's what's happening. So first, let's observe the signs of cosine and sine. So the first quadrant, both cosine and sine are positive. The second quadrant, cosine becomes negative, sine is still positive. Now here below the x-axis, sine and cosine are negative, and cosine is positive, sine is negative. Now, sine is increasing, cosine decreasing. Sine starts decrease, cosine increases. Sine is increasing, cosine decreasing again, and cosine increasing, sine decreasing again. Okay, so let's look once more and notice how the sine and cosine function, they change color too. When it becomes negative, then it changes the color to red. Positive, positive. And then y cosines, x is negative, y is positive. Okay, both negatives. And then x positive, y negative. So this is what we're going to be talking about in this section, basically sine as a function of an angle and cosine as a function of an angle. And here's a first example. We have a picture of a unit circle, and we have the coordinates of the point here. It's 1/2 and square root of 3 over 2. And we're asked, okay, this is extra information. So we're asked to identify the cosine t and sine t. So first you have to make sure we're looking at the unit circle, and this radius of 1 tells us that yes, we are looking at the unit circle. So find cosine t and sine t. Well, the cosine of t is just the x coordinate of our points, so that's going to be 1/2. And for the sine of t, that's the y coordinate, so it's going to be square root of 3 over 2. All right, so that's it. It's that easy. Now I want you to try this problem by yourself. Again, we have a picture with a given point and the coordinates, and I want you to find the cosine of t and sine of t from this picture. I hope that was easy. If not, then let me know. We'll talk about it in class.